Good day everyone, welcome to today's virtual lesson, Earth and Earth Systems. I'm Bonjie, one of your instructors for this session. I hope you are all ready to dive into some exciting learning.
And hello, I'm Cass and I can't wait to teach you all about today's lesson.
And I'm Geri. We are the science majors. Join us as we embark on a journey to explore the fundamental concepts of the Earth and its systems. Here is an outline of the topics that will be covered today. We will discuss the Earth's four subsystems and, of course, the interactions between these four.
So our learning objective for today is to identify the Earth's four fundamental systems across whose boundaries matter and energy flow. Number two, differentiate these four fundamental systems. And lastly, explain the importance of the Earth's four systems in our daily lives.
Now let's proceed to the lesson proper. Here we have the Earth's four subsystems: the biosphere, the hydrosphere, the geosphere, and the atmosphere.
The biosphere, or the zone of life. It contains entirely of Earth's living things. The biosphere is divided by 5 major biomes, which are forest, aquatic, desert, grassland, and tundra. The forest biome is dominated by grasses rather than large shrubs or trees. The aquatic biome includes freshwater ponds, lakes, rivers, and marine ocean. The aquatic region houses numerous species of plants and animals. The desert biome has low rainfall, have specialized vegetation such as cactuses, specialized animals. An example would be camels. They are specialized because they can adapt to its harsh condition. Grassland biome receive just enough rain to sustain grass, but not enough to grow many trees. Lastly, we have tundra biome. It is the coldest biome. Due to cold weather and short growing season, it hinders the tree growth, and because of this, it is also called as treeless plain. The geosphere. It is composed of 3 layers which are crust, mantle, and core. The crust, it is where life is mainly found. It is the thinnest layer. We have 2 types of crust. They are continental crust and oceanic crust. The middle layer, we have the mantle, the thickest layer. The temperature is so high that rocks melts into liquid. The mantle is composed of upper mantle and lower mantle. The upper mantle together with the crust forms the tectonic plates. The lower mantle represents 56% of Earth's total volume. It is hotter and denser than the upper layer. It is made of solid rocks that are much less ductile. The core. When Earth was formed, the heaviest material sank to the center. Did you know the inner core is about the size of Pluto? The approximated diameter of Pluto is 2,380 km, while Earth's inner core is 2,414 km. The core is the most dense layer. It consists of primarily iron and nickel. It is divided into 2, outer and inner core. The outer core is a slow-flowing liquid. The inner core, it is as hot as the sun's surface. It is under intense pressure which keep it solid despite high temperature.
Now, let's proceed with the atmosphere. Imagine the atmosphere as this massive blanket of gases that wraps around our planet, Earth. It's like a protective shield, shielding us from harmful solar radiation and space debris. But it's not just there for protection. It's an essential part of what makes Earth habitable. Picture layers upon layers of gases, each with its own role to play. The troposphere, the layer closest to the Earth's surface, is where all the action happens. It's where weather occurs, where clouds form, and where we live and breathe. It's like the bustling city at ground level. As you move up, you'll reach the stratosphere, home to the ozone layer. This layer acts like a giant sunscreen, absorbing harmful ultraviolet radiation from the sun. It's like our planet's natural defense system, keeping us safe from the sun's rays. Then, there's the mesosphere and the thermosphere, where temperatures can swing from freezing cold to scorching hot in a matter of miles. These layers are like the wild, untamed wilderness of the atmosphere, where the air is thin and the conditions are extreme. And finally, there's the exosphere, where the atmosphere thins out into space. It's like the edge of our planet's atmosphere, where Earth meets the vastness of the universe beyond. The atmosphere isn't just about gases and layers. It's also a dynamic system, constantly in motion. Winds blow, storms brew, and air masses collide, shaping the weather and climate that affect life on Earth. It's like a never-ending dance of air and energy, creating the world we know and love. Now, imagine the hydrosphere as this incredibly interconnected system of water that covers most of our planet's surface. Picture the oceans first. They're like a big player in the hydrosphere game, covering about 70% of the Earth's surface. They're vast, deep, and teeming with life. Then, there are rivers and lakes, like the smaller but still important players in the hydrosphere. Rivers flow from high mountains to low valleys, carving out landscapes and providing water for plants, animals, and people. Lakes are like little reservoirs of water, hosting ecosystems and serving as sources of drinking water and recreation. But it's not just about what you see on the surface. There's also a whole world of water beneath our feet. Underground aquifers, like hidden stores of water trapped in layers of rock and soil. They provide water for wells, springs, and even help to keep rivers flowing during dry spells. And let's not forget about the water in the atmosphere. Water vapor, clouds, rain, and snow are all part of the hydrosphere too. The water cycle is like the heartbeat of the hydrosphere, constantly moving water between the Earth's surface and the atmosphere through processes like evaporation, condensation, and precipitation. Together, all these elements form the hydrosphere, shaping our planet's landscapes, climates, and ecosystems, and providing the water that is essential for life to thrive. It's like this amazing watery world that surrounds us, sustaining life as we know it.
A while ago, we learned about the four spheres of the Earth, and together they make up both the living and non living components of our planet by interacting with each other. So the question is, how do the Earth's systems or spheres interact with each other? I'll be presenting an example to further illustrate the topic. So the example that I will use will be the formation and effects of acid rain. In the atmosphere, it starts when pollutants such as sulfur dioxide and nitrogen oxides are emitted into the atmosphere primarily from human activities like burning fossil fuels, industrial processes, and transportation. These pollutants react with other chemicals in the atmosphere, such as water vapor, oxygen, and ozone, to form sulfuric acid and nitric acid, which are the main components of acid rain. As for the hydrosphere, acid rain forms when sulfuric acid and nitric acid dissolve in water droplets in the atmosphere, forming acidic precipitation. This acidic precipitation falls to the Earth's surface as rain, fog, snow, or hail, affecting water bodies like rivers, lakes, and oceans. Then, when it comes to the geosphere, acid rain interacts with the geosphere primarily through two processes: weathering and soil acidification. Let's first talk about weathering. This is when acid rain accelerates the breakdown of minerals in rocks through a process known as chemical weathering. Particularly susceptible are rocks containing carbonate minerals like limestone. This weathering contributes to the erosion of landscapes, the formation of caves and sinkholes, and alters the composition of soil. On the other hand, soil acidification is when acid rain can leach essential nutrients like calcium and magnesium from the soil, making it more acidic. This affects plant growth and can lead to the depletion of soil fertility. And as a result, acid rain affects the biosphere or the plants by directly damaging foliage and inhibiting photosynthesis, leading to reduced crop yields and forest decline. Also, acidification of aquatic environments harms fish, amphibians, and aquatic plants. It can disrupt ecosystem by altering the pH balance of water bodies, like species composition and biodiversity. This kind of interaction demonstrates how the release of pollutant into the atmosphere can have far-reaching effects on the Earth's spheres, leading to widespread environmental degradation and ecosystem disturbances. Now, going back to the topic, aside from acid rain, I would like you to imagine a scenario where one of the Earth's systems is significantly disrupted. Imagine, just imagine. Now, how might this disruption impact the functioning of other systems? Hopefully, you were able to come up with answers to the questions I just asked. Now, I have another question here. Why is collaboration important in maintaining Earth's balance and sustainability? One possible answer would be that the interconnectedness and collaboration of the Earth's subsystems play crucial roles in maintaining the planet's stability, supporting life, and regulating essential processes. And one last question, I would like you to think hard on this one. As individuals, how can we foster collaboration among diverse communities to address environmental challenges? I hope you are able to answer these questions not just as a learner but also as a human being in our planet. Just as Leonardo da Vinci stated that we should realize that everything is connected to everything else. Now, before we end, let's check your understanding on what we have learned today. Kindly get a pen and paper for you to write down your answers, and together we will check them later on after all of the items. Now, are you ready? Now here's the first question. Which of the following are included in the geosphere? A. Seas and rivers. B. Rocks and minerals. C. Nitrogen gas. D. Water vapor. Now here's the second question. Which of the following is true about the biosphere? A. It is the main source of water on Earth. B. It provides oxygen needed by animals. C. It prevents the penetration of ultraviolet rays from the sun. And D. It compromises all the living components of the Earth. Number 3. What main system do you interact with when you are exploring an underwater cave? A. Biosphere. B. Geosphere. C. Hydrosphere. And D. Cryosphere. Number 4. Which of the following is not included in Earth's subsystems? A. Atmosphere. B. Geosphere. C. Hydrosphere. D. Photosphere. Number 5. When volcanoes erupt, dust and ash particles spread through much of the air and blocks the sun. Which two spheres are interacting? A. Atmosphere and atmosphere. B. Biosphere and atmosphere. C. Geosphere and atmosphere. D. Hydrosphere and atmosphere. And that will be our short quiz. Please check your answer using the answer key on your screen and count how many items you got correct. And now to wrap up our lesson, we learn about the Earth and its systems, namely biosphere, hydrosphere, geosphere, and atmosphere. We also talked about how they interact with each other and how each system is as important as each of them combined. Speaking of the interaction of the systems, I would like to end the lesson with this proverb. Look after the land, and the land will look after you. Destroy the land, and it will destroy you. Thank you so much for listening, and I hope we learned a lot from each other.